Hi, welcome to Parametric House. In this Grasshopper tutorial, I want to show you how you can make this series of parametric ribs inside Grasshopper. As you can see here, we can define the height of these ellipses, which I'm going to explain. Control the size. If I randomized it, I can create random ellipses like that. Control the rotation, first rotation and second rotation, which I'm going to explain. You can also randomize each of these inputs to create different results. Okay. Another thing is the number of count of parts you need, which I'm going to explain, and also the offset, which is the thickness and widths we have here. Also the thickness. There's also a plane which we can control and pick a part of this shape so it stands on the ground. As you can see here, this is completely on the ground and it's ideal for a structure, for example. And then we can create the solids in Rhino like that. Each of these parts, they are in a plane, so we can use that also for fabrication or anything you want to make, maybe a parametric facade or a chair or whatever you want, okay? So let's get started from scratch and learn this step by step. Okay, to get started from scratch, we have to go to the curves input primitive, and we're going to use this ellipse component, which we have to define the plane radius 1 and radius 2. For the plane, by default, it's in XY plane. So I'm going to go to vector and pick up this construct point. And when you give a point to a plane, it's going to think it's an XY plane. So if I connect a point to a plane, you can see that this is going to be an XY plane. We can control the different Z coordinates we want. So I'm going to go to the gene pool, double click this and make this 3 sliders because we want 3 ellipses. The minimum and maximum height you need here is also controllable, and we can give that to the Z coordinate. Okay, that is going to be the first ellipse, the second ellipse, and the last one. Because if we accidentally bring the second one higher and the third one lower, for example, this is going to be the first ellipse, then we're going to jump up here, and then we're going to jump down here. This is going to have some problems with the connecting. So what we have to do is to sort this manually. If a user brings this a little bit higher than the last one, it's going to have some problems. So we can go to the sets list and create a sort list component. And obviously, if this is higher than the last one, it's going to make it 0, 86, and it's going to be the first one, the second one, and the last one. So that is going to fix it by sorting the data here. Okay, that is going to be the center of the ellipses we can control. The next part is to define radius 1 and radius 2. We can Control C, Control V that gene pool and give that to the radius 1. And another one to radius 2. I don't know if these numbers are fine, but I think it's too much to have 180. So I'm going to stick with maybe 20 to 100. And also for this one, 20 to 100. And remember that you can always, a good thing about gene pool is that you can randomize it always with a right click, randomize 100% and create a new one. Okay. That is for the radius 1 and radius 2. Before we go forward and create the structure, we can also play with the plane, XY plane we have here. One is that we can rotate it around the Z axis. So it's going to change the location of the ellipse and create some sort of twisting thing. So vector plane, and you have that here also, rotate plane. And as you can see here, it writes that it's going to perform a plane rotation around a plane Z axis. So I'm going to give that to here. And We can give that to the angle. For the angle, I'm going to right click and make it degrees so it's more controllable. And for example, maybe between 0 and 90 degrees, because too much rotation is going to twist that structure. So for example, as you can see here, this is going to be the first ellipse, second one, and the last one for the rotation. Okay. Another thing we can control here is rotate that around the x-axis, for example, and make it somehow like this. It somehow means that it's going to tilt it up and down, right? This around the x-axis. So the x-axis is going to be the rotation plane, a vector. We can do that simply by rotating the plane with a unique vector. So transform, rotate 3D. We want to rotate the plane. For the center of rotation, you can give that plane to the center. It's automatically going to pick up the center. Angle, I'm going to make this a degree. The axis is the most important part. We have to pick up the x-axis. Vector, plane, deconstruct plane. And give that x-axis to the x. You can also use the origin as the center. So that's also doable. And we can now give a slider also for the second rotation. So this is for the second rotation. You can see that this is rotating it here. And if you want to, you can also double click this and make this minus. I think 90 degrees is too much. So I'm going to say 0 to maybe 60 degrees. But if you want to, you can make it minus 60 to 60. Anyway, this is for the second one. And we can give that as the plane and bring those a little bit forward. You can see that it's rotating that. We can just rotate the middle part, which I prefer to do. But anyway, you can also rotate the first one and the last one too. If you want to, you can give negative numbers to that. Okay. If you want to make it circle, just give the radius 1 or radius 2 1 slider. So that is going to make it completely a circle, which is also interesting for the shapes that you want to be completely radial. And now that we have the ellipses, we can go forward and create that sort of structure. For the structure, it's really easy. We can just use the curve divide and divide the ellipse in a number of division. For example, 3 to 30. I'm going to give that to the count. Increase or decrease that. That's going to be the count. If you want to see the numbers, you can use the display and point list. If I bake that, you can see that the numbers like this 0, 1, 2 goes to 13. Again, 0, 1, 2, 13. Because we want to connect them in this direction, not radial, what you have to do is to, let me show you with a params menu, param viewer. Simplify that too. 3 branches of 14 we had. So we had, this is like the first ellipse, the second one, and the last one, right? Each of them has 14 points. What we have to do is to flip the direction. You can go to, means that 14 rows of 3 points. That is 3 points is like this, right? 1, 2, 3. So we can go to the set tree and use this flip matrix. If you want to see that, it's 14 groups of 3. I can bake that too. And it's somehow like this, 0, 1, and goes up here to 2. You can also use a great tool called display point order. It also shows you how they are connecting. A good thing is that it's really fast because we're not going to connect any geometry here and we can play around with the structure. But anyway, the creating polyline is not really that heavy of consuming the creating the geometry. I can go to curve and create a polyline from that. Okay, that is the structure. We can turn off everything here and we will have the base structure randomized to create different result and have that as the structure. Okay, now that we have these parts, what we want to do is to create some thickness for that. I'm going to go to the curve and use this offset curve. The good reason of that is offsetting is that if I flatten this polyline, if I go to the curve analyzes is planar, give it to the planar thing, you can see that it says true. And as you can see here, all of them are true. That means they are planar. And it also gives you the plane, which is going to be used if you want to use that. But anyway, the reason here is that when you create 3 points, that is only for 3 points. If you make more, it's going to have some problems here. And when you connect that together, the plane can be anywhere. For example, if this is the center of the plane and this is one of the vectors, somehow it's going to make a plane of y in the 90 degrees, similar to that direction, and that can be the plane of that polyline. So all of them are in a plane. We're going to stick with that. We're going to give the polyline to the plane, so it's obviously the default is going to be that curve plane. Another thing we can do is to give a number slider to this, and that is going to be the offset. So I'm going to say the distance we want to create here. There is also a corner for round, if you want to create a corner right here, chamfer, and none. Just not going to connect it. Okay, the sharp is going to be okay. And now we have to connect them together. I'm going to pick up this flatten so we see the groups here. There's also a good lesson here we have to learn. And that is when we have two groups of curve and we want to connect them together, for example, for loft. If I take a curve container and use the shift key to add these together, you can see that they are not adding up. And the reason here is that each offset, when you offset a curve, it's going to add an extra 0, which means that it has been offset that curve. Okay, so they're not going to add up. You can fix that by simplifying the both inputs, and you get groups of 2, and you loft them 2 by 2, which is going to give you the final results like that. Okay, if you want to create a thickness, you can extrude them in the normal direction. For example, you can just give a plane to that, pick up a vector which is going to be in the normal direction, and say extrude. And give this a number. Okay, make it like this without getting into any plugin. Okay, I'm going to bring it up here for those who don't want to use any plugin and get the extrusion. So I'm going to group this and disable it. But if you want to use the pufferfish plugin, which is really great, I prefer to use that because we have tools. We're going to use that in the later part. I'm going to use the surface offset surface and give this okay, the distance on both sides mean, okay, if this is the surface, this direction is going to be the distance input, and both side direction is going to be in this direction. So if I want any thickness here, I can give this one number slider and make this from -x divided by 2 to x divided by 2 to make it completely at the center. And this is going to be the thickness. Okay, thickness. And as you can see here, the surface we made here is at the center of that. And the create solid is also true, so that's also useful if you want to use that in your projects. Okay, now that we have this, if you want to create this structure sitting on the ground, because you can see that it's not, especially if I bake that, we have some problems on the ground, and we want to create that structure, especially if you want to trim it from the top or bottom. I think it's going to be useful. Pufferfish, surface, plane trim surface. Let's give this a point. Again, if we give a point to a plane, it's going to make it XY plane, and that is exactly what we want. I can cut this part. If you want the bottom part, you can just flip the direction. So that is the part we're going to extract. Here to make it flat. Again, if you want to trim it again, you can say, okay, trim the trim part. Because if I connect a B rep to here, you can see that this is the top part, okay? Again, I can bring this up, flip the direction. You can see that we trim the top part also. So we can say from this part to this part, especially that you want to make it completely flat at the top and the bottom. Okay, if you want to bring the structure on the ground because it's just moved up, we can say transform move in the Z direction. And in the amount, we can say, okay, from this point, projected on the ground. Transform, project. By default, it's XY plane. And then we can go vector, 2 points. From this point to the projection, it's going to make a vector of movement. Give that here. Okay, you can turn everything off. And the only thing you can control are these 2 points if you want to. So I've projected this point towards the ground and we have to make it minus, or you can say from minus X, bring it downwards. It's going to snap to the ground. So that is going to be helpful, especially if you want to pick up part from it. It's somehow like a sticky structure on the ground. And this is also going to pick up the top part, as you can see here. Okay. That's good. And we will have that structure. If I bake it, you can see that it's trimmed. So we have an open part for the top and bottom, and it's also separated those two parts. How can we fix this? First of all, because the groups, as you can see here, if I simplify it, it's like this: 0, 0, 0, 1, 1, 1, 1, 0, 1, 1, 2, 0, 2, 1. So they are in two groups of separate parts. Set, tree, shift path. That is going to bring them back into two groups. I'm going to also cap them so they are solid. So we now have groups of two parts which are solid. And then we can use the intersect shape solid union to unite them together. That is going to unite them together. And we can also use the surface utility merge faces to make it into one. So we delete those extra edges and we are good to go. We can give this a custom preview. Remember that is the final B rep you can use in your project. I can make a swatch. And also use a B rep, surface B rep edges to see the edges, so you can see the edges too. Okay. That's all we need here. We'll just delete those, the preview of those points, so we can control that later. Okay, so that's it. That's how you can control this structure and create these interesting results with that. The reason it's jumping here, the only thing is it's an ellipse. If you want to just simply switch to circle, and it's going to create that as one structure. Okay. So remember that you can make it an ellipse if you want to connect that here. Okay. That's it. So that's how we can make it. If you want to decrease the number of count, you can simply by doing that. Create this structure. I hope this tutorial was useful. Thanks for watching and subscribe to our channel. You can also download this example file from our website, parametrichouse.com. See you next time. Bye.